Timers. There are three basic timers that are commonly used in the multi-threading context. Now, why would you use a timer in the first place? Well, timers are useful if you want to do something known as polling. Polling means instead of waiting for a callback method to trigger to indicate a thread is done, instead you may want to check periodically whether or not a given thread is done. So what a timer does is allows you to configure a periodic time for when a certain method will fire. Okay, and the three different types of timers we're going to look at are system.windows.forms.timer that's implemented using the WM timer messages. We're not going to really actually look at this one because we're not dealing with system Windows forms in this class. However, just be aware it's not super precise because it is issued via the UI thread and therefore it is subject to availability of processing cycles off of that thread. System.threading.timer is a thread pool based implementation. Callback always occurs on the thread pool thread, therefore you also have to worry about UI resynchronization. Can also be scheduled for arbitrary start date time. System.timers.timer is an NT waitable timer based implementation. It's configurable support for callback only on UI thread. So unlike the system threading timer, you can set up this particular timer to always execute its callback on the UI thread that you may like on your Windows form or your WPF objects. And it's also support for in Forms Designer as something you can actually drag and drop as a component into your WinForm as well. So the system.threading.timer is pretty simple to use. Notice here we have the using clause for system.threading somewhere at the top, so we don't have to say system.threading every time we want to issue a timer command. And then notice here we, in our main function, start off by saying the timer starts at this time, and then we issue the timer test1, which is actually going to fire the timer off, actually create it and get it going. Then we set an int to 0, and we loop through 0 to 100 for every half a second. Timer test1, as you can see, is the method that starts the timer. It's pretty straightforward. You create the timer by saying timer t equals new timer. You have to pass to it the method that you wish to call back when it is time to be fired. So we say new timer callback, and we give it on timer fired. If you look at the bottom, that is exactly the method we need to call. Then we have to pick an arbitrary value here to pass to it. Just like all the other threading thread start, the parameterized thread start with the begin invoke, we have the ability to pass something to the timer, some context value. In this case, I'm picking the arbitrary value 42 to pass to it. And I'll show you how to reconstruct it in a minute. Then we have to pass two values, indicating when the timer should start and how often the timer should fire after it starts. So in this case, we're saying start the timer in 5 seconds and then fire it every second after that. So the time span class has a bunch of methods for us to convert our standard time units that we use into time units the computer understands. So in this case, we're creating a time span from seconds, but there's also from milliseconds, from hours, etc. So we can say time span dot from seconds 5. That's when we start the timer, and from seconds 1 is when the timer starts iterating after that first 5 seconds. So in the on timer fired method, this is the one that is going to be fired every time the timer executes. We unbox the arg parameter into an int. Remember, we passed 42. Again, it can be any object type. And then we simply say the timer fired at this time. So if you look at the output, you can see the timer started at 10:18:47 seconds, and then we have 10 iterations of the main loop. Why do we have 10? Because we slept for 500 milliseconds, or half a second, for each iteration of the loop. And since the first timer doesn't fire for 5 seconds, that gives us 10 iterations. Then the timer fires at 52 seconds, and then the main loop gets 2 iterations. Then the timer fires again, and notice here, the main loop got 3 iterations. Again, it's because we're leaving context on the main thread. So it may have bunched a call up from just barely crossing some millisecond range to allow for 3 ticks of the main loop to happen within 1 tick of the timer, so to speak. But as you would expect, typically there would be 2 iterations of the main loop for every timer that's fired now, because again, the main loop executes every half a second. So for 1 full second, which is our time span, we need 2 iterations of the main loop. And you can see this continues. I obviously didn't print out the whole thing to 100, but just to demonstrate how this timer works. And this particular timer is fairly accurate because it's running on a separate thread. It doesn't have to synchronize to the UI thread, and therefore it can run under basically its own priority, so to speak. So it's not dependent on that main UI thread for it to be fired. System.timers.timer is a little bit different than the system threadings timer. This one is event-based, where the other one was callback-based. Also notice here it's in a different namespace. It's in system.timers, and because this might coexist with a system threading timer, I put an alias called st in front of that namespace. So yes, I still have to type st dot every time I want to access the timer in this namespace, but I don't have to type in system.timers.timer every time. Again, aliases in the using clause are just for namespace collision issues. And since system threading and system timers both have a timer class, this allows me to avoid that collision. Very similar to the previous example, we're going to loop 100 times and sleep a half a second at each iteration of the main loop. Notice here we call timer test2 to start the timer, and within there we say st.timer, timer equals new st.timer 1000. What this means is we will start the timer in 1 second, and then we will have an interval for every second thereafter. To get our callback, this time we have to create an event handler. So we say the timers.elapsed event plus equals new st.elapsed event handler on timer fired. And on timer fired happens to be the method below. Then, when we want the timer to start, we simply say timer.start. And every time the timer is fired now, we can get that particular timer from the args class if we needed to. We're not really using it in this case, but we can say st.timer timer equals arg as st.timer. That's the object that fired it. And then there is elapsed event args, which will indicate other information. Specifically, it allows us to get the signal time, which was the time the elapsed event was raised. So we can get a specific timestamp for when this particular timer was fired. It gives us a more accurate reading as to how often this thing is firing and whether or not we're getting any delays. So again, we just print the value out, what the time is currently. I again could have said args dot signal time instead of date time dot now. Either one would have been sufficient in this case. So as you see on the right, we start up the timer, and then every second it fires. And again, we have a variable number of main loop triggers in between each timer firing, but typically it's going to be 2 because the main loop will sleep for half a second between each iteration.